Here we go. We have a question: insert in sorted way in a sorted doubly linked list. So you have given a sorted doubly linked list and an element x. You need to insert the element x into the correct position in the sorted doubly linked list. Note here is the doubly linked list is sorted in ascending order. So the description is pretty clear what we want to achieve. Here is the example. We have 3, 5, 8, 10 and 12 and we want to insert 9. So 9 will be inserted here. The input picture and the output representation is very clear. So let's try to build the approach. So we have this test case and let's suppose we want to add, first we want to add, let's say 2. So this is our current or head, we can say head. So we want to check, is our x value smaller than head? In this case, yes, the x value is smaller than head. So first of all, we want to create a new node. So let's create a new node. Then what we want to do, this is our new node. So its name is node. So node dot next will point to head itself. So its next pointer will point to head and head dot previous will point to node. So head dot previous, initially it is null, then it will point to this node and we want to return the node itself. So if value is smaller than head, the approach is very simple. But if we want to insert a value in between the linked list or after the linked list, it's get tricky. So let's try to understand. So let's say we have a value let's say 11. So first of all, we create a node. Then we need to check, is the value smaller than head? No, it is not. So we are sure either the value is greater than, we are sure that value is greater than this. So the value can be inserted in between the linked list or after the linked list. We are not very sure, we want to check. So first we create a pointer head current. So current is pointing to head. So we want to check, is value, we are sure that value is greater than 4. So we want to check, is value smaller than this, means is value smaller than current next value. So we have a condition, actually while loop, while current dot next value, if our x is greater than this, our x is greater than this, so we want to move ahead, current will point to current dot next. So here we are accessing current dot next. So we want to also check, is current dot next not null? So we have this, we are sure value is greater than 4. So we want to check, is value greater than 7? No, yes it is. So what we do, we take a step ahead. So we want to check, is value greater than 10? Yes, value is also greater than 10. So we take a step ahead. So is value greater than 13? No, it is not. Value is greater than 10, but value is not greater than 13. Means we want to insert a node here. So we created a node, then we want to insert a node here. How? So we are sure that value is the node is in between the linked list. So first of all, what we do is current dot previous will point to this. So now its previous is not pointing to this, current dot previous is pointing to this. Then node dot previous also point to current. We establish this link. Let me write the code side by side. So current dot previous will point to node and node its node current dot previous, yes, right. So node dot next, actually I think I made a mistake. Here we have next, current dot next, current dot next will point to node, and node dot previous will point to current. We establish this link, and node next, node next is null. So we want to establish node dot next also. So node dot next, actually we lost a pointer. So this value is not accessible. So we need to be careful while establishing a connection. So let me re-establish the connection. First of all, node next and node previous we want to achieve. So let me take the node to this position. We have 11, and so now it will be more clear. So first of all, this is a node, and we want to connect its previous and its next. So what we'll do is, first of all, we write this node dot previous, node dot previous will point to current here, and then we write node dot next will point to current dot next, current dot next. So this will be here. First we want to connect its previous and its next pointer. Then we want to connect this connection. So it will be current dot next. So I am erasing this connection. Current dot next will point to node this. Then we want to connect this link. So we have to write a condition here. If node dot next is not null, why? So just bear with me, you will get it why we need to write a condition here. If a node dot next is not equal to null, if it is not equal to null, then this node dot next, what it is, node dot next is 13. So 13 dot previous, 13 previous will point to node itself. 13 previous will point to node itself. Same like this, we are accessing current dot previous. So current is 10 and current dot next is node. We can write this uh, like node dot previous, node is 11, node dot previous is 10. So 10 dot next will point to node itself. So current or node dot previous is same. So I hope now you got it. So we want to connect this connection. Node dot next 10. 10 previous is 11. So we want to connect this link. Why we need to write a separate if condition? Uh, in this case, it will work because we want to insert 11 in between. So we just need to return the head. But let's suppose we have this linked list and we want to insert 19. What about 19? So we have current this. Is 19 less than current value? No. So we are sure that 19 is greater than 4, but we want to check, is 19 greater than 7? Yes. So current will move to this position. Is 19 greater than 10? Yes. Is 19 greater than 11? Yes. So it will be here. Is 19 greater than 13? Yes. Is 19 greater than 17? Yes. Is 19 greater than? So it's next is not accessible. So in the while loop, current dot next is null. So that's why we have to write a condition current dot next. So now we want to insert a link. So first of all, we have this, and we are creating a new node. So let me create a new node 19. Then we have this node.previous. Node.previous will point to this node. Node.next will point to current.next. Current.next is null, so it will also point to null. Current.next, current.next is null, so it will reinitialize and it will now point to 19. It will now point to 19. So now this condition plays a significant role. Node.next, this is a node. Node.next is null, so that's why we have to write this condition. Node.next, node.next is null, so we don't need to uh, build the previous connection. So that's about it. We just need to return the head node. So that's why this condition plays a significant role. So let's try to code this. So first we want to create a node. If value x is smaller than head value, then we are establishing node.next and head.previous. So we have built the connection, just return the newly node. Then we want to traverse in doubly linked list. So that's why we have a current pointer. Current.next is not null, and current.next data is smaller, then current will move ahead. Then we want to create a node, its connections, node.next. So this is the newly made node. So node.next will point to current next. Node.previous will point to current. Now node.previous next will point to node. So then we have this connection. Check if next node is not null, then only build a connection. If node.next is not null, then only build the previous connection. Then just return the head node. So let's submit this. Let's talk about time and space complexity. In this function, we only have a simple while loop. So the in the worst case, the time complexity will be order of n and space complexity is constant. If you like this video, give it a thumbs up, subscribe to this channel, and thank you all for watching.